In the previous video, we saw how to create fault-tolerant datasets, that is RDDs, in PySpark. In this video, we look at how to analyze data in the RDDs. Now, Spark offers two broad types of functions, actions and transformations. Now, what is the difference between the two? Actions do not modify data in RDDs, whereas transformations do. So, in order to see data using actions, we do not need to create new RDDs, whereas it is mandatory for us to create new RDDs to store the modified data from transformations. Now let's look at the most frequently used actions in transformations. So let's go ahead and create a Spark context. So it is the same 3 steps from the previous video. And let's wait for a bit to initialize our Spark context. Now that's done, let's import data. For this demo, I will be using the ECDC dataset on geographical distribution of COVID-19 cases worldwide. Now I'm going to name my RDD data, RDD, and because it is an external file, I will use the sc.text file command to get my RDD. Let's start with the actions and transformations. Now the take action returns n elements from a dataset. So let's take 5 elements from the RDD. So as you see, the first row is the header row and the other 4 are data points. So the take action picks 5 elements from an RDD and displays it to the user. We also see another action which is similar to take, which is called the top action. It returns the top n elements in an RDD. Now let's look at another action, which is the count action. It returns basically the size of the data set, as in the number of records in it. So let's go ahead and do that. So this data set has 13,624 elements. Let's move on to a slightly advanced function, which is a map transformation. What it does is that it applies a function to each element in an RDD and stores it in a new RDD. So let us do this. Let's explore the data a little bit. We see that the entire set of columns is stored as a single string. And let's see how many columns we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 columns. Each element is also stored as a separate string. Okay, so if we need to analyze data, we should probably split up each column individually and then see if we can aggregate or generate any kinds of insights. Great. Now, I would like to split the entire string into the number of columns, but I will not use all columns. I'll need the first 6 columns, which is the date representation, the data, the month, the year, the cases, and the deaths, and also the country. Let's do that. So I use a lambda function, which I define as x.split with column, because the column is the delimiter, and save it as cases RDD. Let me go ahead and do that. Okay, so we see that each column has gotten separated, and I've only gotten the columns that I need. And out of the top 5, only 4 of them are actually output data. The first one is a header, so we need to eliminate that. I would like to extract the first row from the RDD and save it as a header. In order to perform any kind of action or transformation on an RDD, we need to parallelize the header and convert it into an RDD. So let me parallelize header and call it head. Okay, we had that. And what I would like to do now is filter out the header row from the RDD, for which I have the filter transformation. So I define my lambda function as line, where line is not equal to header. And I'm going to save the filtered data in cases RDD. So now the header row has been removed. So let's see what the top 5 elements are. Voila, there's no header. Okay, now the first three columns correspond to date. The first column is the day, the second one is the month, and the third is the year. Now, I would like to join them together and create a proper data format. So I will use another map transformation using another lambda function, and I'm going to put together the date components, and I'm going to call it the dated cases. Let's run that and see what it returns. So this is how it looks. So we do observe that the date is still a string format, which means we can't sort the date in a chronological order. So now let me print out the keys. An RDD is stored in two ways, either by individual values or as a key value pair. Any action or transformation that is done by key needs to have the key specified. Let's see what the keys of our dated cases RDD is. Okay, they are the dates, which is the first element in the tuple, in each tuple actually. Now let's see what the values are. Okay, the second part in the tuple, which is another tuple containing the country, the total cases, and the deaths, is the value. Okay, so now let's calculate the total number of confirmed cases, which is basically the sum of total active cases and deaths. So we need to define another function and we need to whip up the map transformation another time. So currently the deaths and the confirmed cases are also in the form of strings. So we need to convert them into integers and then add them up. So let's do that. Okay, so we have the date, we have the country, and we have the total confirmed cases. Let's do something a little more advanced. Let's group the elements by date and sort the countries alphabetically. We need to apply two functions. We use the group by transformation. Now, what this transformation does is it groups elements by a user defined function on the values and stores them as iterables for each group. We map the values from each list in the iterable and convert it into an RDD. So the first step, which is the group by, is here, and I am grouping the cases by the date, and I am sorting the results. Now let's see what the top three elements in the resultant RDD are. Okay, so you see the key is the date, and we have sorted the groups by date first. And while I'm in the task of sorting, let me also quickly whip up the max and min actions. So you can print the maximum and the minimum from a set of elements. And then we move on to the sort by transformation. Now, the sort by transformation sorts elements in an RDD by a key function, assuming the RDD contains elements as a key value pair. Now, what I'm going to do is I would like to sort my data frame, firstly based on the country, and then by the number of deaths. By default, the order of sorting is ascending, but we can always switch the ascending argument to false and make it a descending order. So let's go ahead and do that. So what happens when you give multiple sorts is that the outermost sort, the one that you mentioned at the fag end, gets applied first, and then the inner one, and so on. So, so what I expect to see here is basically the sort based on the total cases first, because that was the last argument we gave, and then sorting by country, which is what happened here. Now, just for fun, let's switch it around and see what happens. Now, this should give us the RDD sorted by the country first and then the number of cases. Now, let's see what happens. I believe you can appreciate the difference. That's it for today, and keep learning.